If you gon' do it, then 他にの次 Yeah, everybody just talk, nobody really do it なんならやるまでしとけよ秘密に誰か
Material list MPU-65T. It's a micro-electromechanical system which consists of a 3-axis accelerometer and 3-axis gyroscope inside it. This helps use to measure acceleration, velocity, orientation, displacement, and any other motion-related parameter of a system or object. Arduino Uno. It's a microcontroller board developed by Arduino and based on Atmega 328 microcontroller. It consists of a USB interface, 14 digital I/O pins, 6 analog pins, and Atmega 328 microcontroller. Jumper. They are low cost and used to connect hardware such as sensors, Arduino boards, and breadboards together. The connectors are available in male and female with a 2.54 millimeters. Modulo Bluetooth HE05 allows use to connect all projects with Arduino to a smartphone, cell phone, or PC wirelessly. Bluetooth tool is I2C channel. Protoboard. It is a construction base for prototyping of electronics. Gear model are mechanisms that regulate the speed of electric motors, making them work at a certain rate. Wooden sticks and boards. This is served for the structure. Click and battery. 9-volt battery connector with cable. Ideal to power any device that requires 9 volts. It's used mainly in connection boards, breadboard, or to power any prototype of electronic circuit. Tires. It is a device that rotates on its own axis and is used to transport loads from one place to another to perform various tasks on various materials. H-bridge. An H-bridge is an electronic circuit that is generally used to allow a DC electric motor to rotate in both forward and reverse directions. They are widely used in robotics and power converters. Finally, a power supply is used to power an electronic device continuing with its desktop computer DAM. The power supplies power to the motherboard, CPU, graphics cards, HDDs, SSDs, fans, CD players.
As we can see, the MPU is connected in the following way. The VCC is connected to 3.3 volts, the GND to GND, the LCL to analog 5, the SCA to analog 4, and the int to pin 2. The motherboards from bridge H to the Arduino are in to pin 5, in 1 to pin 6, into to pin 7, and B to pin 10, in 4 to pin 9, in 3 to pin 8. The rear motors are connected to bridge H through a power source, and the Arduino is connected to a 9 volts battery. Its operation is that when the robot is decanted to one side, the robot rotates to one side, the same to the other side, keeping in the state as a circus tripper walker.
And here we have the programming code of our balancing robot. This is a programming code that we used before to make this activity. And well, first of all, here we have the four libraries that we include in the programming code: the PID1, the motor controller 1. This one is about the communication with Arduino, and finally one of the MPU. Here we have this conditional if that includes the wire.h library too, and we define the min speed of 20, and we start the declaration of the MPU to work with the library in our programming code. And well, here we have the MPU controls that are made in order to have more precisely control with the MPU, such as the init of the MPU, the FIFO count, and other things that if we met, we can control it in a better way. And this is the orientation of the MPU, the axis that we are going to use. This is all the declarations about the PID and the original set point and other stuff that we are going to use in the programming code more forward. And these are the important ones: the KP, KD, and KNI, which are here in order to help us to make the balancing robot and to make the PID work in a better way. These values are the ones that we used in our own balancing robot, and although it didn't work as it has to, it work in a certain way. I mean, if we have our robot falling, it tried to put it in order and keep stable, but it didn't have the it wasn't strong enough to be stable in having this state always. And then here we have this constructor about PID, which are called in the library, the speed of the motors, and the controls about the motors by using the L298 by this constructor too. And well, this is our other protocol things that we have in this programming code to collaborate between the libraries. I mean, like the control that we have with the motor and the control that we have with the MPU to be more in symbiosis. So if we continue, here we have, for example, the library about the communication of the Arduino and the wire library too. Here we initialize it. We start with the MPU library, and here we have other things about the sensibility and the movements that we are going to have with the lectures, with the readings, I mean, of the MPU, and conditional if about it. like if it doesn't detect something, if it is stable or not, if depending on each value that we have by the ratings. Well, this is the behavior that it is going to have. Then here we have the error system that helps us to operate the PAD, so we can have the right speed at the right time with the right motor in order to keep it stable. And if we continue, well, this is the order. Well, this is everything that we got in the code. It doesn't have the Bluetooth thing, but well, our H-bridge model didn't work. 2 of them didn't work, so we failed in this.
We already know the operation of the MPU tags to pass practice. It was not difficult to understand the operation of this component in this practice. However, the challenge in this new project was to understand and apply PID control in something that worked with our own hands. The first thing you did was watch the video from the playlist, was added to the assignment test, and after combine each of the demonstrated the project. We chose the one we considered the best option to be able to work on it. So we met in my house to talk about the project in person and start working in it. We bought the remaining materials and meet to finish it later.